Hi, 4th grade, Ms. Kachabata here. This is the video for week 6, day 4, and this is aligned to the Eureka Math Module 5, lessons 20 and 21. Okay, so our objective today is I can use visual models to add two fractions with related units using the denominators, okay? So for our daily warm-up today, we're going to be subtracting. I can see that some of these are whole numbers, some of these are fractions, and some are mixed numbers. So if you haven't done this yet, I want you to go ahead and pause the video, and you can either time yourself if you have a cell phone with a timer or a watch nearby, or you can just work at your own pace. That's totally fine. And then when you're ready, I want you to press play so we can go over them together. Okay, so assuming now that you have finished and you've pressed play and you're ready to check your answers, we are going to go through each one. So I'm going to start with 2 minus 1, and that's pretty easy. We know this in 4th grade. 2 minus 1 is going to give me 1. Okay. Next, we have 2 halves minus 1 half. All right, I can see that these denominators are the same. So if I subtract here, I'm going to get 2 halves minus 1 half is going to give me 1 half. Next, I have 1 whole minus 1 half, but I know that if 2 is my denominator, I can rewrite 1 whole as 2 halves, 2 over 2. I know that is the same thing. So I know that 2 halves minus 1 half is now going to give me 1 half again. All right, next I have 3 minus 1, and we know that 3 minus 1 is 2. 3/3 minus 1/3, you should have gotten 2/3. Okay, 1 minus 1/3, again, since I am dealing with thirds now, I know that I can rename this 1 whole as 3/3. And now I can subtract 3/3 minus 1/3 is going to give me 2/3. Next, I have 8 minus 1, which is 7. Next, you should have gotten 7/8. Next is 1 whole minus 1/8. Again, I'm dealing with eighths now, so I'm going to take this 1 whole and I'm going to write 8/8 minus 1/8 is going to give me 7/8. 5 minus 1 is 4. Going up to the top in the next column, 4/3 minus 2/3 is going to give me 2/3. 1 and 1/3 minus 2/3. So this is a little tricky, but I know, again, 1 whole is going to be equal to 3/3. So if I have 3/3 plus this 1/3, that means all together I'm going to have 4/3. So now I have 4/3 minus 2/3, and that's also going to give me 2/3. Okay. Next, I have 1 and 2/3 minus 1/3. Same thing. I know that 1 whole is equal to 3/3. So now I have 3/3 plus 2 more thirds, and that's going to give me a total of 5/3. So 5/3 minus 1/3 is going to give me 4/3. You can keep it as it is, or you could rewrite this as a mixed number as 1 and 1/3. Next, we have 7 minus 4, which is going to give us 3. Now I have 7/5 minus 4/5, which is going to give me 3/5. Then we have 1 and 2/5 minus 4/5. So I'm going to rename this 1 whole as 5/5. And 5/5 plus 2/5 is going to give me a total of 7/5. 7/5 minus 4/5 is going to give me 3/5. Okay. 1 and 4/5 minus 2/5. Again, take out that 1 whole, make it 5/5. 5/5 plus those 4/5 is going to give me a total of 9/5. And 9/5 minus 2/5 is going to give me 7/5, which you could also rewrite as 1 and 2/5. Okay. 5 minus 3 is 2. 5/4 minus 3/4 is going to give me 2/4. And we have 1 and 1/4 minus 3/4. Again, take that 1 whole, write it as 4/4. Take that 4/4, join it with the 1/4, and now you have a total of 5/4. Now we have 5/4 minus 3/4, which is going to give me 2/4. Okay, go ahead and review that warm-up, and then we are going to go ahead and move down. Oh, there's nothing down, okay? We are going to go ahead and go to the next page. All right, so I'm just going to quickly go over this, and then I will be going through the let's try with you. Okay, so here we have the new learning. So up here, we've actually done this. We're just going to be adding fractions with different denominators. And to do that, we're going to create equivalent fractions using tape diagrams, right? So we've done this before. This is where we have, okay, 1/5 here, or 1/2 here, I'm sorry. And now I want to know, how can I make that into eighths, right? How could I split that up into 8 pieces? So they took the next tape diagram and they drew 3/8, okay? Then over here, they had both of their tape diagrams and now they took the 1/2 and they said, how can I split that up into eighths? And it came out to be 4/8. So once they had their two equivalent fractions, 4/8 plus 3/8, they got their total of 7/8. Going on down, another strategy they're showing you here is just using a number line to estimate if the sum is going to be between 0 and 1, or if it's going to be between 1 and 2. So we had 7/10 and 1/2 here, all right, 7/10 plus 1/2, and they know that 7/10 is a little bit more than 1/2. So if I'm going to add 1/2 to a fraction that's already bigger than 1/2, I'm going to get a total that's between 1 and 2. Okay, so again, they made equivalent fractions. They turned 1/2 into 5/10, and then they added it together to get 12/10, which is between 1 and 2. Go ahead and flip that page. Again, this is just some more new learning. Up at the top is using multiplication to find equivalent fractions, which we've done so that we can add. And then on the bottom is the same thing as before, where they are adding two fractions with unlike denominators using a tape diagram, but this time your sums may give you a fraction that is greater than 1. Okay, so you can go ahead and flip to the next page, and we're going to start working through these problems together. So you're going to scroll down to where it says let's try. All right, and it says 1/2 plus 1/4. Okay, so what I want you to do is I want you to draw 2 tape diagrams. Okay, so here is one tape diagram, and here is another tape diagram. Okay, just make those the same. There we go. All right, now we are going to show 1/2 on the first tape diagram. All right, so I'm going to split this into 1/2. And I'm going to shade in one of the units. All right, next I'm going to divide this into fourths because my fraction is 1/4. So I'm going to divide it in half and then divide it into fourths. And here I'm going to shade in one piece, which is 1/4. All right, so now I need to decompose my my tape diagram with the bigger unit size. All right, so here the units are much bigger, the halves are much bigger than fourths. So I'm going to take these halves and I'm going to split them up into fourths. All right, just like this. Okay, so now I have created this into fourths. So I can see here that originally I had 1/2, okay, and I had 1/4 here. And now that I divided up my 1/2 into fourths, I can see that it's also the same as 2/4. So I can decompose the fraction into 2/4 plus 1/4, which I know is going to give us 3/4. Okay? Now, it says draw a number line to represent fourths and then write a number sentence. Okay? So we have 0, 1/2, and 1. Okay, so I want you to think, all right, 1/4 is going to, I'm not sure what that dotted line is, but I want you to think, okay, 1/2 is going to be, 1/4 is going to be about right here. Then we have 1/2. And then we're going to go over just a little bit more to go over 1/4. And that's going to give us 3/4. Okay, so now we can see that if we start at 1/2 and we go over 1 more 4th right here, that's going to bring us to our 3/4. Okay, go ahead and flip to that next page. Now here it gets into your problem set, and at the top you're going to use a tape diagram because that's what the directions say, and then for at the bottom it just says solve, so you can use a model if you need to, or you can just make like units. Okay, and then anytime you get a sum that is a fraction greater than 1, it wants you to write it as a mixed number. Okay, so we are going to start with A. It says 3/4 plus 1/2. All right, so I'm going to draw 2 tape diagrams. All right, I have my 2 tape diagrams, and now I'm going to make the first one represent 3/4. So I am going to take my pen and I'm going to split it up into 4 pieces. And then I am going to shade in 3 because 3 is my numerator. All right. Then I am going to go to the next one, and that is going to give me 1/2. All right, so I'm going to split it in half, and then I'm going to shade in 1 of the halves, and that's going to give me 1/2. Okay, so I need to make these have the same denominator, so I know that there's no way that I can take my 3/4 and decompose it into 1/2. So I'm going to go to my 1/2 and I'm going to decompose it into 4ths. All right, and I'm going to do that by splitting these up. I'm going to use a different color, like this. All right, split each half in half, and now I can see that 1/2 is also the same as 2/4. Okay, so if I add these 2 new fractions together, that's going to give me 3/4 plus 2/4 is going to give me 5/4. I know that this is a fraction greater than 1 because my numerator is greater than my denominator, so I'm going to make this into a number bond to help me pull out my whole. So I can ask myself, since my denominator is 4, how many fourths do I need to make one whole? I need 4/4 to pull out to make one whole. And now, once I've done that, I'm going to ask myself, how many fourths do I have left to get to 5/4? I have 1/4 left. So I can see that my answer is going to be 1 whole and 1/4. Okay? Moving on to B, I'm going to do the same thing. So the first thing I want you to do is I want you to draw 2 tape diagrams, and I want one to represent 2/3, and I want one to represent 3/6. Okay? Draw my there are my tape diagrams. Okay. Again, I'm going to show 2/3 on the first one by splitting it into 3 pieces. And shading in 2 of them. And then on the next one, I'm going to show 3/6 by dividing this into 6 pieces. And shading in 3. Oops. Okay. Now, I am going to make these have like units, all right? And I'm going to do that by taking my pen and I'm going to decompose my thirds into 6ths, okay? And I'm going to do that by drawing a line between each third and splitting it in half. Now I have 6 pieces, and I can see that 2/3 is also the same as 4/6. Okay? So now I can add these because I have like units. So I'm going to say 4/6 plus 3/6 is going to give me, whoops, I wrote 16ths. Okay, is going to give me 7/6. Again, I know this is a fraction greater than 1 because my numerator is greater than my denominator. So I'm going to put this into a number bond, and I'm going to pull out the 1 whole. So I'm going to ask myself, how many sixths do I need to make 1 whole? I need 6/6. Okay. And now how many do I have left over to get to 7/6? I have 1/6 left over. So that means my final answer is going to be 1 whole and 1/6. All right. Now, I'm going to move down to the next one. If you want to use a model, you can. I'm going to show you how to do this with multiplication, all right, like we've done before. But if that doesn't work for you and you need to do the model, I'll go back at the end and show the model way. So you can either skip ahead to where I solve it doing the model, or you can stay now for the multiplication and then just stop the video once we get to the model part if you don't need it, okay? So using multiplication first, I'm going to look at these two fractions. So I have 3/4 and 2/8, all right? And I need to add them together. But I know that if they have a different denominator, I cannot add them together like this. So I'm going to find the LCM, okay? The least common multiple. All right, and we do this by skip counting. Okay, we want to find the first number they both have in common. So I'm going to skip count by 4 and 8, and the first number they have in common is the least common multiple. So 4, 8, 12, all right, and then 8, 16, 24, all right. I can see that 8 is the first number they have in common, okay? So I'm going to create 2 new fractions with 8 as the denominator. All right. Now, I'm going to go back to 3/4, and I'm going to start with the denominator. I'm going to start with 4. And I'm going to say 4 times what gives me 8? 4 times 2 gives me 8. So whatever I multiply on the bottom, I have to multiply up top. So 3 times 2 is going to give me 6. So 6/8 is an equivalent fraction for 3/4. Then I'm going to do the same thing to 2/8. But I notice that 2/8 already has 8 as a denominator. So I don't have to do anything to that fraction. It can stay the same because it already had the new denominator that we were creating. So now I'm going to add 6/8 plus 2/8. I know that it's going to give me 8/8, which is the same as 1 whole. Okay? Going on to the next one, here I have 4/6 plus 1/2. So I need to find a common, the least common multiple between 6 and 2. So again, I'm going to go up here and I'm going to skip count 2, 4, 6, 8, 10. And you just have to do a little bit. And then if you don't find a least common multiple, you can keep going. All right, then I'm going to say 6, 12, 18, 24. All right. So now I can see that 6 is the least common multiple between 2 and 6. So I'm going to create 2 new fractions with 6 as the denominator. All right, and I'm going to use that multiplication again. Again, I can see that 4/6 already has the denominator of 6, so I don't need to change this fraction. I can just keep it as 4/6. Then I have 1/2. So I'm going to say, okay, start with my denominator. 2 times what number gives me 6? And I am asking about 6 because 6 is my new denominator. 2 times 3 gives me 6. Whatever I multiply on the bottom, I have to multiply up top. So 1 times 3 is going to give me 3. Now I'm going to add these two fractions because they have the same denominator, so I can add them together now. 4/6 plus 3/6 is going to give me 7/6. Okay? I know that 7/6 is a fraction greater than 1, so I'm going to put it at the top of a number bond. And I'm going to ask myself, how many sixths am I going to need to make one whole? I'm going to need 6 sixths to make one whole, okay? And now if I have pulled 6 sixths out, how many more do I have left in 7/6? I have 1/6 left. So now my final answer, written as a mixed number, is going to be 1 and 1/6. Okay? Now, if you don't need the tape diagram method, you can go ahead and turn off the video. You are done. Congratulations. If you skipped over the multiplication part because you would rather do the tape diagram way, I'm going to go over that now. All right? So, I am going to erase these the way that they are now. Okay. All right. And we're going to solve them using the tape diagrams. So looking at the first one, all I want you to do is I want you to draw 2 tape diagrams, and I want you to represent 3/4 and 2/8 in them. Okay, so in the first one, for 3/4, I'm going to divide up this tape diagram into 4 units because 4 is my denominator. And I'm going to shade in 3 units because 3 is my numerator. All right. Now I have 2/8. So this is 3/4. I have 2/8. So I am going to split my next tape diagram into 8 pieces. Okay. And I just do it this way to make them even, or somewhat even. And I am going to shade in 2 pieces because 2 is my numerator. All right, and that shows 2/8. So now I'm going to look at the tape diagram with the bigger pieces in it, right? The bigger units. So I'm going to look at 3/4 and I'm going to say, okay, what can I do to make this, decompose this tape diagram into eighths? All right, I have 4 pieces, I need 8 pieces. So I'm going to go to each section of the tape diagram and I'm just going to split it in half, right? Because I have 4 pieces and I want to make 8 pieces. So I'm just going to split each one in half. And now I have 8 total pieces. So if I look at what's shaded in now that I have 8 total pieces, I can see that 3/4 is the same as 6/8. Okay? So now I have my new fraction, 6/8 plus 2/8. Okay? And when I add 6/8 plus 2/8, which I can do now because they have the same denominator, I'm going to get 8/8. And I know that 8/8 is the same as 1 whole. So 1 is my final answer. Okay? Moving on to B, again, let's start with our first step, which is to show each fraction on a tape diagram. Okay. I have to say I really like drawing these tape diagrams on this because when I do it on the whiteboard, they are never this pretty or this straight. Not that it matters. You know I always say that. Okay, so I'm going to show 4/6 first. So I'm going to have 6 pieces. Okay, because 6 is my denominator. And I'm going to shade in 4. Okay, so this shows 4/6. And I'm also going to show 1/2. So I'm going to split this up into 2 pieces, and I'm going to shade in 2. Or 1, I'm sorry, 1/2. Okay. Now, I'm going to look at the tape diagram with the bigger pieces. So I'm going to look at the tape diagram representing 1/2. And I want to make this have the same number of pieces as the other one. So I need to make this tape diagram have 6 total pieces like my other tape diagram. So I'm going to take my pen and I'm going to split up, since I have 2 big units, I'm going to split up each one into 3 pieces because again, I want to make 6 total units. Okay, now looking here, now how many are shaded in now that I have 6 units, I can see that 1/2 is the same as the fraction 3/6. Okay, so I'm going to come over here now and add up my new fractions with the same denominator. So I'm going to say 4/6 plus 3/6. Okay, and I know that 4 plus 3 is going to give me 7, so I have 7/6. I can see that this is a fraction greater than 1 because my numerator is greater than my denominator. Okay, so I'm going to put this into a number bond and I'm going to ask myself, how many 6ths do I need to make up 1 whole so I can pull out 1 whole out of this fraction? And I know that since my denominator is 6, I would need 6/6 to make 1 whole. Then I'm going to ask myself, how many more do I have left over in 7/6? And I know that I have 1/6 left over. So my final answer is going to be 1 whole and 1/6. Okay? If you have any questions, please reach out to me. I have posted all the anchor charts, but if you need any help, I'm happy to get on Microsoft Teams or FaceTime or something with you. Please let me know how I can support you, and I will see you guys on the next video.